Today I'd like to go through tip number 5, try solving the problem backwards. I'd like to go through this concept, and for this example we're given a problem named rat attack. Let's go to this problem. So I will try to explain it shortly. This map is kind of Manhattan map, and those squares are buildings, and those lines are streets and streets intersections. The idea is now in the city there are a lot of rats, and all of them live on street intersections, like somewhere underground. And our task is to place a gas bomb on intersection to kill as many rats as possible. And for what we're given some coordinates of rats and amount of rats on coordinates, and we're given a radius of it's not really a radius because bomb will explode in square form. So like in this example, d equals to 1, and bomb placed in the center destroys all of those intersections. And with d equals to 2, it would destroy this, and like bigger square. Now I'd like to draw this, draw an example we are given. 4, 4, 10, 6, 6, 20, and the radius would be first line contains the strength d of the gas bomb, and second line contains the number of rat populations. What is follows the line containing 3 integers? Oh, the first line contains the number of scenarios in the input. 1. Okay, got it. So we have 2 rats populations. Let's draw them. This would be a coordinate of intersection 4, 6, and we know that here leaves 10 rats at this intersection, and at this intersection we know there are 20 rats, and it would be reasonable to place a bomb at coordinate 5, 5. So we can kill this guy and those two, but they are empty, and this one too. Yeah, it's really important because we may place so our task is to place only one bomb and to kill as much rats as possible, as many rats as possible, not to place it here and avoid this population, and not to place here and avoid this population. We need to kill them all. So yeah, now I want to dive into explanation why we should use a concept of backwards thinking. The reason is time complexity of straightforward, like naive approach would be too much, because our constraints are that amount of houses, our fields would be 1000, more than 1000. And so this is our grid, and D would be, let me clarify this, up to 50. Okay, up to 50. And like, yeah, straightforward approach would be go to coordinate 0 0 and check where bomb radius, this D, how many squares it can kill, and what amount would be if we place the bomb in the coordinate 0 0. And then we go to 0 1 and place bomb, try to place bomb there and calculate it again. So we would end up with 25 squared multiplied by D squared, because we have to check every cell, every intersection. And yeah, so we have to, like, there would probably be 24 intersections if we have 1025 houses. I will clarify this later. And yeah, multiply by D squared, because we have to make this check, like bump radius every time we go to another cell. So how backwards approach may be applied here? The idea is to make, this is not my idea, like there is a guide in this book. It took me some time to understand it. Yeah, you see the same calculations I made, I just want to make it on, like, with my own words. And yeah, the idea is to calculate only those squares where there are reds, because you may see that we're given our field is really huge, like 1000 per 1000 cell, 1 million cells, but we're given only two coordinates, only two of them. So there is no need to process every coordinate, and we can create, and like I suggested in the book, we can create an array, like a similar grid of values, killed 4, 10, 24, where we will place, like every time we have this rat population placed. No, like initially we read the input, place all rat populations, and then we go through, then we go our each rat population and try to calculate how many rats could be killed if we place the bomb here, like in this cell. But this approach won't give us this result between two populations. Like it will never give us coordinates 5 5, because we will have only values in this killed array, like the same values, 10 at coordinates 4 and 4, and 20 at coordinates 6 and 6. And after this preprocessing, we will have values of how many rats will be killed if we place a bomb on rat population. Let me check out again a hint from the book. Oh no, yeah, my mistake. So the idea is to process it somewhat differently. Not to check every location of rat population, but to check, start with this rat population cell and go to d squares, d cells at every direction. Yeah, so like when we process it this way, we will have such a result. I'm thinking how I can compress this to have lower fields. No, I want a bigger grid. 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 7, 8. So initially we had this 4, 4, 10, yeah, we remember, and 6, 6, 20. But what we do now, we go from 4, we start with field 3, 3, because it will be in radius of a bomb if it's placed on this red population. So this is our red population, and we have to check this area and calculate calculate every cell here of how much reds like it would contain if placed there. And then 6, 6. So our result would be, if we process this cell, 10, 10, 10, 10, 10, 10, 10, 10, and here we will have 30, because this is the intersection of two red populations. Like bomb placed here would kill this guy and this guy. And yeah, we got 20, 20, 20, 20, 20, 20, 20. So yeah, this seems reasonable, and let's try to implement this in code. So what we have for tests? Initially, we have to read the input. And okay. Tests bigger than 0. We should read D and in 10, and then we'll have this and lines while and this one is bigger than 0. And yeah, obviously we have to create a grid. Yeah, so what I wanted to check is whether there are 1025 cells or no, we're given coordinates of intersections between 0 and 1024. So yeah, it should be 1025, 25, given between, okay, maximum population is 255. Yeah, so we will be dealing with sum, and this number is given for us to, so we can consider dealing with overflow of integer, so we don't have to use long probably, and int would be sufficient. Okay, so well, also I want to have this killed array, and list of coordinates to then go over them, and there's a row and column okay. So I'm creating this list to store coordinates where we placed red populations on the grid, to then go over this list and fill killed array. Because if we just filled grid and don't remember coordinates, there will be no way to process to fill killed array in n time, in O(n) time. We will have to go n, not n, but 1000 squared complexity, which is too much. Okay. So initially intro in extend column and pop population. Okay, please add new coordinates raw column and grid row column equals to population, obviously. Yep. So yeah, this is our pre-filling. Having D, okay. Now it becomes somewhat interesting, because we will have to process every coordinate for int I equals to 0 less than list size I plus element equals to list get I. And now I'm thinking how to implement this calculation. Yeah, I will probably need a helper method. Int calc surroundings, which will need yeah, let's make those variables global. Killed. Because I don't want to deal with these parameters passing, and also we'll need D, which is here. And also I want to make this size. This would be more convenient than writing 1000 every time. Size D read what private, okay, don't care. So for this we have to make given D for each cell. Calculate coordinates for element, and I will have to do 2 loops, and this would be sum equals to 0, and I will have to go through each row. No, I'll have to go row equals element row minus D, right? 4 to 3, yeah, this is reasonable, okay. And the row is less than element row plus D. And 2 more constraints, row bigger than 0 and row is less than size. Yes, this is important. Row plus plus. We can copy this for column. Column. And return sum. And here what I would do is sum plus equals agree. Row and column. Yep, just write a loop, not that hard to implement. But I have to do it again, I think. Because I have to check for every Z cell, for every surrounding cell. Interesting. Field. Well, but this would probably make our like this would go O n times per d squared so d to fourth, and maximum this would be, I remember, 20k per 50 to fourth, and 2500 to squared. Well, this will be probably too much. Well, I have to think about some optimizations. What I'm thinking now, we can go. What we can do, we can place to this every cell population plus grid. So yeah, there is no need to go to this loop again. No need to quadratic loop in quadratic loop. And what we can do, we can just column and plus grid, row, and column. So what's wrong? Replace. Okay. I think it should work. Let's check how it will work. Let's create another grid. 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We know we're interested in those cells. 6, 6, 5, 5. Okay. So what it would do, this algorithm would place this 10 here, 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 and here. And then it would place 20 over 10, which would be 30. And here 20, 20, 20, 20, 20, 20. Yeah, this is exactly what we wanted. And yeah, I'm just thinking. Okay, so this step is finished. No, this would be yes, this value. This is for our pre-processing. And then we have to go to what's wrong. We have to go to calculation of this point. Yeah, we finished with pre-processing, and then we have to determine the most optimal bonding position, which can be done in n² operations. Why n²? Let me think. So we can, like, why do we have to go twice over each entry? Highest entry in array killed should be not n², but 1000², or not? Why do you think? I thought this, like finding of highest entry in array killed, it may be done first initially when we pre-process. We can just place like variable maximum. Oh yeah, maybe we can do this, even avoiding this lookup for highest entry. We can do this in place probably. If it has this int max with value -1, and what else? And coordinates max c, no initial. What else? Well, yeah. Yeah, why not? So this may work. And if killed row column bigger than or equal maximum, sorry, bigger or equal, and yeah, sorry, I could be stupid. and just bigger. If it's just bigger, then we simply override this. So we place killed, roll, column, and max c will be equal to new coordinate of row column. And else if killed row column equals to maximum, and max c doesn't equal to null. Well, it shouldn't be, yeah, it definitely won't be equal to null. And max c row is bigger or equal, yeah, bigger or equal than row, and max c column is bigger than column. We should overwrite again row column max c equals to new coordinate row column. Let's see whether this worked. And just do this. What we should output coordinates and value max row plus space plus max c column plus space plus maximum. Yeah, this is a loop. What's wrong? May produce null. Yeah, that's true. I don't know, I believe it's guaranteed that this value will exist because we have at least one red population. But yeah, let's check out. Oh no, I wanted to do this. Okay, let's run a simple test. 6620. Well, this is definitely not what I wanted. Oh no, yeah, this is like element row and element column. Yeah, what should I do? Element row, element column. 551. No again. Not yet. 30. Let's run debug. So killed 0. Okay, it's not that convenient to watch the whole array. Killed row column 3 equals to 10. 3. Yeah, that's correct. And we update our maximum. Okay. Column 4. Okay, go. Let's go just ahead. We're interested in row 5, column 20. What? Shouldn't it be element 6? How it? Well, let's do it again. element for 4. Okay. Oh yeah, I know where is the mistake. It should be included. Because yeah, and this row should be included too. Because I didn't process it. It was stupid. Yeah, I should. Well, no, not really. Let's check it again. Killed 10. Updated. Okay. Column 4 element still form 4. Column 5. Okay. This is what I expected. This should be 10. Still 10. Okay. Now go to column row 4. Element the same. Okay. 3, 4, 5. Nice. Row number 5. Column 3. Column 4. Column 5. Fine. Maximum is 10. Reasonable. Column 5, 5. Yeah. Killed. It should be 10, and this is 10, and this guy is 20. So why it doesn't? How? What's? Oh man, where did you find this 40? Like for real? How did you get this 40? Boy. Well, let's make some more steps. No, swing out, no, control, no, still. Well, let's make it previous value. And this guy is population. We can actually make it somewhere here. And I want it to be previous plus population. Why is it hard? Copy input. Well, I forgot about your previous. Yeah, let's add it to watches, previous, and population. Population, add to watches. So just to be clear, like all grid cells and killed cells initially are zeros. This is what Java array initialization, like this is how it works. Go over killed. What is F1? Doesn't seem to work. Well, not interested. Okay, 10, relation 0, 10. Well, that's reasonable. 10, $10, element 4, 4, 10, 10. I'm waiting when we change our element. and this is the moment. Now we do with C6. Population is 20, okay, that's correct. But why I will like previous 10, okay, and 40. How? 10 plus 20. Oh, okay, I'm stupid. Okay. I just have to plus population because, yeah, I calculated it twice with this plus equals sign. Yeah, my mistake. Okay. Well, it happens. It happens. I believe now it should work. Let's test it again, but probably everything should be fine. Oops. Yep, 5530, and this is correct. Let's do some more test cases. There is a cool debug button in UVA Online Judge, and where some people share their test cases, because I'm lazy today and I don't want to try to build my own test cases. Copy, get accepted output. I hope there won't be any null pointer exceptions. Okay. Well, so, well, how it's, what should I output if no exception is possible? So this test case is, let's explore some 500 test cases. That's a lot. That's a lot. Radius 2, radius 1. I'm just like scrolling and trying to find something which may cause null pointer exception. And, like, let's maybe do this if no, like salt something, and place a debug sign here. Copy this and debug it. I'm actually surprised why how does null pointer happened, because well, this seems made happens if population is negative. What is the number 494? This means this is 6 plus 12. This is 18th test case. Okay, my Sublime would be better. Uh, 1, 2, 3, 4, 5, 6, 7, 8, 10, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, this is the case. And what's wrong with it? Yeah, I got it. So I think the problem is, you see, there is a really huge radius, like 40, and starting coordinate is 13 or 9, and I placed this condition in my for loop, where it is. Yeah, that row should be bigger than 0, and row is less than size. But immediately when we place like 9 minus 40, it would be less than 0. So I would remove this guy and or maybe not. No, I wouldn't remove this, but what I would do, I would place here an kind of equation. I wanna start the loop not from negative number, but at least from 0. And this should fix my issue. And I wanna finish my loop here at the maximum of size -1. And I should do the same for this guy. Minimum or 0 and maximum over size -1. Let's test this. Is that it? What's wrong? Is there an infinite loop or what? What happened? Well, okay. Oh yeah, I forgot. Yeah, sorry. This should be 1, which is amount of test cases. Again, 1, 2, 3. Well, why? Why? No. Oh well, yeah. Okay, sure. Maximum or minimum, yeah. And this vice versa. Because like when picking minimum, like minus 100 would be obviously less than 0. So yeah, my mistake. 1, 37, 0, 36. Okay, this may work. Hopefully there are no more bugs here. And is this a oh well. Well, it was pretty long, so I hope it would pass bad idea, I'm sorry. I hope it would pass time limit because it took so while. Copy, and I want to compare like our outputs with accepted solution, accepted output, and my own output. For first look, there are no differences, but there is actually one difference. Well, hopefully my algorithm, like I didn't go through what was mentioned, like which can be done in n-squared operations, find coordinate of the highest entry, and I went my own way, but hopefully I did it correct. Well, where could be my mistake? Case number 286. How should I find it? 286. Well, 286. Oh well, okay, cool. I figured out the issue. Like maximum number is correct, 104 and 224. Like this is correct. I also have those numbers, but my coordinates are wrong. That x should be less than. I placed the code for this when like killed equals to maximum, but I should update it. Oh well, yeah, only when row is less than and column is less than current value. This was kind of easy. I'm dealing with, you know, I'm having test cases, some test cases, some accepted output. And this makes like solution much easier. Well, what's wrong? What's wrong now? Row should be less than. Okay. Row should be less than this guy, or well, this becomes somewhat complicated. Or what should happen? Or max row equals to row, and in this case I want column be less than previous maximum column. And I want to remove this guy, it's not necessary. Too less, too much quotes, too less. Oh, no. So I want to, let me clarify. If current row is less than maximum, is previous maximum row, update it. If they're equal, if current column is less than, update it. Well, this should work. It really takes a while. I think it's like one of the most time requiring problems I dealt with. Since it's not necessary. Yep, they are identical, and I would like to try to send my solution. Remove this guy, submit. So let's see whether like my code solution will be accepted or not. Yep, accepted. Awesome. So I'm glad to say that this is what I was able to get a solution during pre-processing, like which was this part without this code was supposed to be a pre-processing, but like adding those few lines saved me from going into another like I don't know how many, 4 million operations, 40 million operations. Yeah, a lot of operations. For 1 million operations. How many? Well, it doesn't matter. Just my code is somewhat better than this suggested solution, and I'm really happy to say that. Well, for this problem, that's it. I hope I will publish. No, I really definitely will publish this code. Maybe it will be helpful for someone, and I highly encourage someone to try to solve this problem with suggested algorithm using this AND squared algorithm, because I wasn't able to come up with it.